Okay, the video is about solving simultaneous equations using two different methods, substitution and then elimination. Just let you know that you may need to review or rewind parts of this video because there are two methods being shown in here. Okay, let's consider 37 equals 3x plus 4. If I asked you to solve that, yeah, I think, if you've done linear algebra before, which viewers of this video should have, you'd be able to solve that two-step equation. What if I said solve y equals 3x plus 4? So not 37 equals 3x plus 4, but y equals 3x plus 4. Well, you might know that as a linear equation, but you can't solve that. So you can solve it because there are two things unknown. It depends. You'd need a value for y to be able to solve for x, or the other way around. You need a value for x substituted in to solve for y. So you can't solve with just one equation. You can't solve for two unknowns. So the number of unknowns must be a match for the number of equations, or vice versa. The number of equations must match the number of unknowns. So number of equations must match the number of unknowns. They're the symbols. Okay, so we need two equations, and if we have two equations, and we have two unknowns of the same type, the same two unknowns like x and y, or a and b, we can solve them together at the same time, and that's called simultaneously. And before we get into the algebra part of it, we can express this idea graphically. So parallel lines never meet, and there's no points of intersection. And if you're given two parallel lines, if you're given the equations of two parallel lines, you can't solve them simultaneously because there'll be no solutions. The solution happens with non-parallel lines, and the point of intersection is where the two lines or the two equations have the same x and the same y value. That only happens at one point, and that will be the solution for the simultaneous solution. So the simultaneous solution is the intersection point. So it's the value for x that works for both equations, and it's the value of y that works for both equations. But when you've got a fixed x and a fixed y, you're talking about just one point only. There it is. Okay, let's look at the first method, and it's called substitution. Substitution is usually used when at least one of the equations has one pronumeral as the subject. Now all that means y is a subject there, okay? X is a subject. It's by itself. Anyway, so how do we do substitution? It means substituting one equation into another. You have to be experienced enough to choose sometimes between substitution and elimination. Or sometimes it says you must just use substitution, or you must just use elimination as the method. So it depends. But you need to be experienced enough so that little hints like this stick in your memory. Okay? Here's an example. Because y is the subject, we can use substitution. So first thing you do, if you're given two equations and you have to solve these simultaneously, you write the two equations down. That's step one. Step two, you label the equations. Now usually you call it equation 1 and equation 2, like you see there, or some people call it equation A, equation B. As long as you give them a name and you write them down like that. Now in this case we can substitute equation 2 into 1. Now you always write down always write down your annotations, your steps. What are you doing? Explain to your reader what you are doing. You should always do that. It's good setting out. So what we're doing is putting this equation into this equation. So 2 into 1. But what does that mean? That means if you look closely, whenever I have y, I could write 3x plus 4 instead, and it would still be true because y equals 3x plus 4. So that would be true still, wouldn't it? We can see that happening here. So writing equation 1, this is equation 1, they've rewritten it just here. You can see all the parts. There's x, plus, now the y has been replaced by 3x plus 4 because y equals 3x plus 4, so that's your y. Now we've got like terms, so we can add them. So we've got x and 3x makes 4x, and you've got the 4 continuing there, and it equals 8. Okay, and we just solve 4x plus 4 equals 8. We solve that in the normal way, and we take 4 off both sides and divide by 4, and x equals 1. Now that we know x equals 1, we have one of the two solutions. We want a solution for x, and we want a solution for y. So we have one of them. We need to find y, and we substitute again. So you can see that we've got equation 2 here. With equation 2, we've rewritten it down here. So really the author should have said using equation 2. You should be telling your reader what you're doing with these. Okay, so just getting rid of that to declutter a bit so it's not too busy for you. So we're writing equation 2 down here, and there it is, except for you'll notice there's a difference. There's a 1 there instead of the x. There's a 1 because we know x is 1, and so we can find the value for y. So y is 7. So x equals 1 and y equals 7, so the 0.17 is the simultaneous solution for those two equations, and it's also the point of intersection. Here's a quick example. So we have to solve these by substitution. Again, label your equations, write them down. Substitute 2 into 1 because this one is the subject, and we've got corresponding bits here. 2x minus 3 minus 3. Now instead of y, we're replacing it with x plus 3, and that equals -8. We can collect like terms and solve, and so we get our answer, x equals -1. Substitute again. You substitute the value of x equals -1 into one of the two equations. It's easiest to substitute it into this one. You could also do that one, but this one is easier, so you might as well go for that one. So we've got y equals x plus 3, but we know x equals -1, so we've got -1 plus 3 is 2. So the simultaneous solution is x equals -1 and y equals 2, and it's also the point of intersection. The last part of the video is elimination. Elimination is generally used when both equations are in this form here. So something times x plus something else times y equals some number. Okay, and these are examples here. See, compare them to the form, and likewise those. Now, important advice here: when there is no matching pair, like in the second example, you might have to multiply one or both equations by a chosen factor. I'll go through some examples and I'll draw that out. So, solve the following pair of simultaneous equations using the elimination method. So here's the elimination method. What you do is you write the two equations down. So we've got x plus y equals 6 and 3x minus y equals 10. We write them down. We label them because we have to refer to them. Now what we do is put the x's vertically aligned and the y's vertically aligned and the constant answers vertically aligned. Everything is vertically aligned. Now in this one here, this is a straightforward one. You are allowed to add and subtract equations. These are called, if you do maths and senior, you might hear about things called EROs, and they're elementary row operations. And what that basically means is you can add or subtract equations, and it means that you can multiply equations by a number. Alright, and you can multiply it by positive or negative values. So I'm going to show you all of that. So this one here, we can add equations to each other, and that's what we're doing. Okay, so we've got to add like things. So we've got 6 and 10 is 16. That's pretty obvious. And x and 3x is 4x. And this one here, take a close look. Y and negative y is 0. 4y equals 16, therefore x equals 4. Now the second part of elimination is substitution. So elimination is only for phase 1, which is here. Phase 2 involves substitution. So it's the easy part. So now that we know x is 4, we can sub it into one of the equations. It doesn't matter. They've chosen equation 1 because it's easier. So instead of x plus y equals 6, we got 4 plus y equals 6, and so y is 2, and we have a simultaneous solution. Please note that you can always substitute your answer for x and y into the original equations, and you can check your work, and that way you know you got it right. Now for the hardest part. Sometimes you don't, when you're using elimination, you don't have matching pairs. What that means is, just like in the previous example, we had one y here and one y there, and we had positive and negative y, and that was very easy to deal with because they gave 0. You won't always get that, so you've got to manipulate things. Remember, you can multiply equations by a number. I'm going to show you that now. So this is the hardest part. You may need to play this again. So we line them up like before. What we have to do is multiply equation 1 by 2, and you can see that that's there. We've got equation 1, and if we multiply equation 1 by 2, we've got to multiply y by 2 is 2y, minus 3x by 2 is 6x, and 1 by 2 is 2. Give it a different name. We call it equation 1a, or we call it equation 3. Now we're going to go equation 2, take equation 3. So we've got 2y, take 2y, which leaves 0. Okay, note that you can choose to add or subtract equations. This time it's subtract, and we've got a 0 there. See, it's called elimination because you're eliminating either x or y. You're eliminating one of the types of unknowns, and so we've got one equation and one unknown. Remember the beginning of the video. Go back to it if you've forgotten already. So 5x take negative 6x. Now be careful, 5x take negative 6x, so that's 5x minus negative 6x, which is the same as 5x plus 6x. That's where they get the 11x from. So be careful of that there. So x equals 1. And then again it's just down to substitution. Sub x equals 1 into one of the equations, it doesn't matter which one, and you get y equals 4. So the simultaneous solution is x equals 1, y equals 4. This last one here, we've got 3x plus 2y equals 6 and 5x plus 3y equals 11 in part B. These are the hardest ones of all because the matching pairs don't come easy. You actually have to multiply both equations by something to get something common. And if we multiply, these ones need the most practice. If we multiply equation 1 by 3 and equation 2 by 2, we do get a 6y, and then we can subtract and eliminate the y's. It doesn't matter whether you eliminate x or y, it doesn't matter as long as you eliminate one of them. Then once you've done that difficult part, you can then substitute in, as you see at the end, and there's our simultaneous solution. Again, that was a fairly dense video, and you may need to watch parts of it again because there were two methods.